Welcome back, everyone, from the lunch. So our topic now is hybrid search. What does hybrid search refer to? See, here's our reality. We have in the RAG pipeline, retrieval augmented generation pipeline, we have a two-phase thing. We have the LLM, right? We have search results coming off from a given query. A query goes into a search, semantic search.
Asif, can't see your screen.
Oh, we can't. Let me take care of that. Here is my Zoom.
For some reason, it's not streaming on YouTube yet, Asif.
Oh, it is not streaming on YouTube. That is another problem. Thank you for pointing that also out. Let me see what's going on.
Oh, I see it's coming up now.
Okay. All right. So the only problem we need to solve is this screen sharing problem, right? Yeah, I know why it's partnered with me. Now it should show up.
Yep.
So our basic setup was that you would take the query, you would feed it into the semantic search engine. You would get the K results, K top results. The results would go into one section. Yeah. Query would also go into another section here, which was meant for query. Remember, the search results. And you basically here have a system prompt saying, to answer the question, the user query, use the information in the search. I mean, I'm just putting it in a very informal way. You remember that we put it in a much more formal language. Information in search results below. And that you give it to the LLM as a complete prompt, and out comes your answer. This is your RAG in its simplest form. Are we together? This form of RAG has a name to it these days. While a year and a half ago, this was a big idea. Today, much has happened. RAG has become a very involved and used, like industry deployed thing. A lot of research has happened, a lot of methods have come up, research has come up. As you know, there is a whole course on RAG we are offering starting in October. By the way, if anyone of you are interested, you are most welcome to register for that course, but that will take away your Sunday also. So you'll have to have some tough conversations with your family. Saturday and Sunday both gone. Anyway, that's that. Now, there is a problem here that we are going to focus on. The problem is we implicitly want good search results, isn't it? Now, we are going to, and this will be our first departure from what is called baseline RAG. We are going to make it better. And the first step we'll make better is by asking this question, is semantic search engine the best way to search for answers? And this is a good question. See, semantic means a query. It has enough for a machine to understand what you're talking about, isn't it? If somebody just puts in the word bank, you have no idea. Yeah. Bank is a homonym. It has multiple meanings. And the semantic search engine will then produce some results, may not be so useful. And this is, so there are situations where traditional search engines do quite well. Right? Remember the keyword search engines, the keyword-based search engines? Keyword slash TF-IDF. A TF-IDF stands for term frequency, inverse document frequency. Right? Inverse document. Basically, what it means is when you search which documents match a particular term, two factors that should be considered is first, how prominently this term occurs in that document, but more importantly, how really important this term is compared to the other terms in the search query, right? Like, for example, the word "the" is practically useless. It's a stop word. On the other hand, the word, if I were to use the word very specifically and say semantic search or semantic embedding, the phrase, that phrase has a lot of significance, right? It means something very specific. And you want documents that match it. So traditional search engines, the most popular algorithm they use, which I sort of simplified it by saying, in a very, very naive sense, they are the keywords, key, and the documents D1, D2 that contain that keyword. Do we remember that?
Yeah.
We said that. Now, with the augmentation that you do TF-IDF, and there is a formula which is based on TF-IDF. There's an algorithm which has been the workhorse of the search industry called BM25. Right? I leave studying BM25 algorithm, the formula. It is a celebrated formula. It is a particular formula, which is IDF, a term frequency, and then there are some additional things that go into the BM25 formula. I won't go into that because we can spend an hour or so just explaining that. Suffice is to say that it does do traditional search very well, and it has been the workhorse of the industry, right, in tradition. Now, experience-wise, we see that when users give good queries, they explain things well, then semantic search does quite well, very well, much better than traditional search, which is why semantic search has more or less taken over the world. But there are situations where traditional search still does well. So that brings us a question. Can we get this search? So let us focus only on the search results here. Can we take this approach? Given a query Q, you do a fan out. You do a keyword search. Let's say BF25, right? You do a semantic search. And you add the results of both of them to create search candidates. Are we together? You do this. Now, there are more reasons to fan out. Let me talk about some more reasons why you want to fan. Sometimes what happens is you don't keep just one database index. For example, you may have a database index for general use. Let me just call it general population. Now, because you deal with engineering, you're the engineering team, you might have access to a database search index, which is only available to engineers. Engineering. You guys must be doing it if you're using Elasticsearch, etc. There must be security rules saying that the salespeople cannot go into engineering documents because you want to make sure your company's secrets are not shared, no, are stolen. So things are on a need-to-know basis. Engineering DB, and the same way you might have an engineering DB keyword search. Keyword. This is a keyword. This is semantic. This is semantic. This is a engineering DB. Engineering data or engineering text. you're doing, right? Likewise, you might be doing, let's say you might have taken your source code, your Git repository, and you might have done the same thing, right? Somewhere in here is a Git repo. There can be your Jira tickets or your ticketing system issues, right? So you realize that we have a lot of fan out, whether it's semantic or keyword. You might be searching through multiple databases, multiple systems, and each of them will produce its search candidates. Right? Now, we will only focus on search. This problem is not RAG. It has a high impact on RAG, but even as a search engine, you now have a problem. The problem that you have is you cannot be showing results from all of these to the user because some results are better than others. You need to re-rank. The fundamental problem that you face in all this search and recommender systems is re-ranking. Re-ranking of the results that you get from different sources. Does that make sense, guys? Right. And by the way, this is how, and this idea that I'm bringing forth is the foundation of information retrieval and recommender systems. Any mature recommender systems these days is based on search engines, similar technology, but at the same time, you use multiple recommenders, right? Good mature enterprise recommender systems will have a host of recommenders. Each recommender, let's say for this user may recommend 10 different products. The whole question is, all of these products that come through, what you say is that each of these individual subsystems are producing candidates, search results or recommendation candidates. You call them search candidates, right? Search result candidates, if you want to think of it. Candidates. These have to be re-ranked in terms of relevance. So now the question comes, how would you know? How would you judge it? Whether it's relevant or not. There are many measures, and I'll today tell you how to measure the efficacy of a search engine. That is it, right? See, the only way you can improve something is if you have a metric to measure it with. Right? For regression, you use mean squared error, mean absolute error, MAPE, this, that, Hoover loss, so many things, R squared. Classifiers, again, you have accuracy, precision, recall, F1 score, area under ROC curve, so on and so forth. Search, if we are doing search, it is today we'll discuss with measures of search. Measures of search efficacy. How effective is your search, or what are the metrics? People often abbreviate it to say search metrics. What are the search metrics? So that's a topic. But let us say that you do have some metric in mind. The two metrics that we will talk about is MAP and MRR. There are many search, but these two are the most popular, and we will talk about them shortly. But assume for the time being, and I'll park this for a bit, that you know which metric you're using. Then what is the job of your re-ranker? The job of the re-ranker is, given a query and given this big black box in which all this magic is happening, what does the end user see? They sent in a query, they got back results. So your metric, let me write this metric as mu, right? What you want to make sure that, right, which methodology produces for you, which re-ranking technique produces for you the highest metric value. That's quantifying it. Does that make sense? So we will think about how to do that. We will go back to our old notion what was I remember when I said that you do sentence BERT, sentence encoder, I said that there is something better than even sentence encoder, but that is computationally brutal. What was that? Okay, guys, I'll whet your recollection, but you need to go back and review. See, I said that when you take a BERT model, BERT-based or encoder model, BERT trans. So we covered, remember, did we or did we not do the research paper reading of BERT?
We did.
We did. And what did I say? BERT contains two sentences, S1, S2. You prefix it with a CLS token, right? Each of these, sentence 1 comprises of token T1, 1, T1, 2, whatever number of tokens it contains. And then this one will comprise of, again, T2, 1, T2, K, M tokens, K and M tokens. These two sentences go in, and then, of course, you get embedding vectors here. You get a hidden state vector, CLS. You get a CLS for 1, 1. Each of the tokens in sentence 1 and sentence 2. Isn't it? And now, you also realized, we said, that if you feed it into a softmax, let's say, or just into, forget a softmax, we can, for the sake of this, we can just put a logistic unit, a sigmoid unit. I take only the first vector, HCLS, into this. What does a logistic function produce? Some probability. This probability of this CLS to be something, right? Now we can train this machine to produce the probability or the measure to be that if two sentences, so let us say that if this is a query, sentence S1 is the query, and S2 is some document, some text. It will tell us how similar or how relevant the document is to the query, isn't it? We can train it to do that, right? To predict the relevance of this document to this query. And it does a very good job of it. Right? In fact, I mentioned to you that when BERT came out, despite being computationally brutal, companies like both Google and Microsoft, both the search, Google search and Bing, they went head on with BERT, despite the cost, right? And the cost was brutal. Why is it brutal? Because two sentences need to propagate through this very complex, let's say 540 million, in those days, massive model. Today is just, it's only half gig. Yeah. But nevertheless, big model. And it would go through all of the attention layers, the feed-forward layers, the everything, right? All to produce similarity with respect to just one document. But when you are searching a corpus of, let's say, 10 million documents, the corpus size is 10 million, you realize that every query has to be compared to, let's say, 10 million docs, right? Or if I add it to be 100 million, even worse, isn't it? Are we together, guys? So it is not computationally feasible to use a method like this, though it's a gold standard. It works really very well. And so the whole point of sentence embedding came from the fact that we can take an intermediate step. What we can do is we can train a sentence BERT, sentence encoder, using contrastive laws such that you take a sentence as, you take a reference sentence, let me just say A, you take a similar sentence and you take a random sentence, right? This is and you train the model. You train the model to maximize what? Similarity between AI and SI, and minimize similarity between AI and some random statement, isn't it? So this was your contrastive loss. Using contrastive loss, you created a machine that would always produce vectors, embedding vectors, which you store in your vector database, right? But the question therefore is, you gained a lot in speed, because what you can do, you can go and all your 100 million docs, you can make it into 100 million vectors, right? And so at inference time, theoretically, you need to compare the query. You take the query, convert it into a query vector, and do a k nearest neighbor search into this pool of 10 million vectors. Even in the most naive implementation, a similarity is a cosine. It's just a dot product, right? Cosine similarity. It's a vector compute. It goes blazing fast compared to passing it through inference, complete inferencing machine like BERT, isn't it? So inference time is extremely cheap. What makes it even better is to use approximate nearest neighbor methods like FAS algorithm. And so FAS with its various indexes like HNSW and this and that, that makes it like ridiculously fast, because you're not doing 100 million comparisons. You're at most doing 50, 600, 100 comparisons. And so what happens is that a vector search returns you blazing fast results. Actually, it is shocking how fast it returns, especially if you have a good thing. Towards that, today, I will now recommend that you all explore and install a particular vector database. Now, I made you do all of it by hand, deliberately, because that was a way to learn it. But now that you have learned in your previous homework project, now start a transition over to Qdrant. Are we together? Transition over to Qdrant. It is a blazing fast database. It will help you create searches very efficiently. Now, you can do very fast searches. You can get back results. What have you lost? Generally, no gain comes without some compromise, some loss. What is it that you lost? Approximate nearest neighbor, you lose some there. Also, there is a complication. You're not comparing the text directly, which is the gold standard. You're comparing the embedding vectors, right? So what happens is that you lose some of the precision of the query, isn't it? You lose some precision, some goodness, search result quality. So it's a compromise in quality. And so the question to ask is, can we recover that quality? Right? That is the big question. Can we have the performance and not give up on quality? Have the cake and eat it too. How would we do that? So that brings us to the topic of re-rankers, right? What you do is, even when you are doing with only semantic search, not even doing hybrid search, just semantic search, what you could do is take a query, pass it through a vector DB search. So suppose you're looking for 10 results, right? Top 10 results, say, for, you just want to make sure that your top 10 results, top 20 results, whatever, are extremely high quality. But you realize that if you do vector DB search, ANN search, you make compromises at two places. Yes, you're comparing vectors and you're doing approximate search, right? So what you can do is you realize that, see, instead of 10, suppose I were to go and get 50 results, let's say, or 30 results or whatever. Generally, you can have a reasonable confidence that the best 10 results are sitting somewhere in there. Am I making sense? That the best of the results are sitting somewhere in there because you got a larger pool of candidates, right? Search result candidates. I just say, so 50 candidates. I will now use the word that's used in the industry, 50 candidates. You get 50 candidates, and now there's a question. What can I do? I got 50 candidates. Somewhere in there are my 10 best results. How do I find it? And the answer is I can go back to my gold standard. Right? I can go back to the BERT, or I can go back to the full encoder and do this. Because behind, I take query and a search result SI. Right? Pass this into a full re-ranker. BERT, let's say BERT re-ranker. By the way, a BERT has now become Robert, etc., etc. And now there's a whole, you can look up, there are benchmarks on which is the best re-ranker at this moment. But I'm using BERT because we did the BERT architecture. Right? Now what can I do? It will produce, for each of them, it will produce a score, Q, SI, and all I need to do is sort the scores and pick those documents which have the highest score and move it forward, isn't it? So I can do just to improve my semantic search better. And by the way, I told BERT, anybody would like, knows where am I leading it all up to? Which one would I be actually using? It is in my RAG class, but let's just say that Colbert. Yeah, Colbert too. And one of you attended my Wednesday. Anybody attended my Wednesday paper reading on Colbert and on Kolpali? You were there, right? So you know what I'm talking about. So BERT is, of course, I'm just using it as a reference to explain the idea, but it will get far more sophisticated when we move forward. So there is a way to re-rank. But the fact that I have a re-ranker, now I can go back and say, hey, why just re-rank the search results that come from vector search? I can even give the same query, fan out to, let's say, keyword search, and feed that into the candidate pool, right? And I can have multiple databases, all of these. See, doesn't matter where I produce candidates from. I can produce candidates from wherever, right? And I might be searching many different data searches. So listen to what I'm saying. Search many different search indices. So one of the search index may be on engineering documents, one may be on source code, etc. Different databases, indexed using either the traditional BM25. What are some of the most popular BM25 engines out there in the industry? Keyword search, keyword search. Elasticsearch, Solr, OpenSearch, etc., right? These are all very popular. Or semantic search. So you can harvest, and you see that it's a scatter-gather approach. You took a query, simultaneously fired it across these different individual things in your ecosystem, in an enterprise environment, right? And from that, you got search candidates, but you can rest assured that you don't need to worry. Because usually if you search two different databases, the biggest problem is now each will say that here is my relevance ranking, and there's no way to mix the two up. No. But you can, because you have the gold standard. But don't you take a performance hit? You don't take a performance hit because, see, you're not comparing your query against 10 million or 100 million documents. You're running this BERT, this re-ranker, which is expensive, no doubt, but against just 50, right? Or 30 or something like that. Suppose your batch size is just 32 or 64. In a single shot, all of the similarities will come out, isn't it? Because remember, these transformers don't take one data, they take batches. In one mini batch of inference, or two mini batch of inference at most, you can shove the whole data set through. Make sense, guys? Right? And so this technology, this way of doing it is called hybrid search. And that also brings us to your homework or the project today. You have some documents that you have done semantic search of. I want you to do this. Don't go install whole of Elasticsearch. It's a bit of an annoyance. I mean, if you want to go ahead and do that, right? But there is a Python BM25 library. And in fact, there's a Python 25 library, S library also. I put it on your course portal. Just directly integrate with that. So then what happens is, do traditional search in your document, do semantic search in your document. Semantic search you already are doing, isn't it? Now create a candidate pool by putting them together and feed this candidate pool through a reranker. So where do I go get a reranker from? Let me show you. And where's the sample code to do all of that? If you go, for example, to SBERT, the reranker here are called cross encoders. Do you see this, guys? Cross encoder, right? The usage is very, very easy. Given a query, do you notice that it is comparing the query, the text against text? There's no embedding happening here, right? It's a direct sentence, the text-to-text comparison. And then there is a retrieve and re-rank. It gives you the pipeline. This is what I was talking about, re-rank, isn't it? And so here's a bit of code that can help you do that. Re-ranking is one of the things that most people doing search implementations in-house, 99% of them, they just don't do it, right? They should. They should. Because when you look at the search metrics, even if that's the only thing you're doing semantic search, you will see there is a huge improvement in your search results when you do re-ranking, right? So now, and then of course, the ideal standard is do a hybrid search, do traditional search, do semantic search, take the results, re-rank them, right? Now, I'm going to talk about the metrics that we use for doing search. Like, how do you know whether your search is, how would you know that if I use the re-ranker, the results are better? First is that visually, when you inspect the results, you'll see that they're better, right? But more importantly, there are metrics, and I'll tell you what those metrics are. So let me go into those metrics. One of them, I'll start with the simpler one of them. Mean Reciprocal Rank, MRR. What does MRR mean? What it means is, suppose you create a validation data set. You take a query Q1, and in the documents, you happen to know which document is the best answer to this query, right? You should know that. You deliberately say, here's an easy way. Pick a document, read it, and then from there, reverse engineer a query of which that document is the best fit. You can easily do that, right? Manually do it. It's a human task. You can do that. So let us say there is a D1, Q2, there is a D2, which is the best document, right? you know the answer, which is the best result for this particular query. So you create a validation data set like that. Create about 100 or so. And now what you do is you fire against your big search ecosystem. So remember, at the end of the day, from a black box perspective, a query goes out, results come out, R1, R2, let me just say R20 come out, right? 20 results come out, top 20 results here show. So now what you do is you ask this question, Q1 produced R1, R2, R3. Where was document D1? That is the best answer to this question. Where was it? Right. So this is rank 1. So the order is literally, the position is called the rank. Right. R4. 4. Let us say, where would you want to see it? R1. Ideally, you would like to see it ideally, you would like to see it here. Isn't it? Worst case situation, it's not even there, right? Or a bad situation is R20 is equal to D. What? Isn't it? So now let's convert this into something, a measure of goodness. So 20 is bad, 1 is good. Right? But if you want to make something out of it, where the higher the goodness, the better it is. A score, the higher the score, the better it is. How would you do that? If 20 is bad and 1 is good, one easy way you can do that is 1 over rank. Inverse it, right? So 1 over 1 is 1, good. 1 over 20 is a tiny number, 5%. Bad, right? So but one query is not good enough. You can repeat this now for the second query, Q2, which will produce its own search results. Somewhere in there will be the answer, whatever it is. So now what happens is you have a reference of, let's say, 100 queries, Q100. Now what happened? You maintain a table, Q2, Q3, Q100. And would you agree that I can come up with the rank 1 over rank 2, 1 over, what was the rank of the best result in 3, 1 over rank 100. So far, so good, right? For every query, you just figure out at what rank did the real answer show up, the real document show up. So you have all this. So how good is your search engine? It is summation of this rank. So what are these? These are reciprocal ranks, right? So you would be 1 over 100, sum over reciprocal ranks. Average it out, right? Isn't it? That is why it is called mean. Now you understand where the word comes from. Mean reciprocal MRR. Right. The next one is mean. So this one is easy, guys. Did you absorb it? Any questions? Pretty intuitive, isn't it? Now,
the only question here is that your D1, the judge.
Yeah. That's a human judgment. Somebody has to create it. Somebody has to review it and say, yes, it makes sense. So see, at the end of it, your search, you really have to create good data set, good benchmarks, internal benchmarks. This is where engineers came. So one basic rule is never, ever ask engineers to do it. Yeah, engineers are lazy. they will do bad things. You get people who get other people, product managers or documentation people, or some people who are passionate about it, coming up with those data sets. QA people also are terrible. Any person with an engineer title should never be given a task that requires patience. It's a basic rule I've learned. All these, say, I've been in 15 years in strategic leadership roles. The first rule that you know as a VP is you need to complement every engineering division with a division, which is what I call the patience division. Documentation, proper benchmark data, labeling, etc., etc. I'll give you a real life example. I needed to create, see, this is 2019. Yeah, different queries, different documents. Yeah. Yeah. Queues are queries. No, let us recap what I just said. I said, go create a validation set. Go pick, like you need to handcraft queries, and you need to know exactly in your corpus which document is the best document to answer. So one easy way to do that is find unique documents in your corpus and then study it, and then out of that, create a query that document alone will be a good answer for. Right? Yeah, you can do that. So you do that. So I'll give you a real life example. This is 2019, 2020, about that time frame. I'm doing exactly this. Semantic search, etc. I'm working for a company that is one of the leading learning giants. I lead the research and the development of all AI. I own all AI in this company. It's a big billion-dollar company. So I needed to create data for this sort of thing, for that. On every subject, I needed some good text. They could be YouTube transcripts, they could be actually articles, etc., etc. I asked engineers to, I thought, okay, engineers, they'll do it, right? Guess what? First week, I saw results come in. Engineers will be happy writing tons of code. And these are, by the way, the best of the lot, you know, with IITs attached to them, many of them with PhD, most of them actually, many of them with PhDs, masters, this, that. They came up with a handful of them. I went ballistic on them, right? Next week, they came out with more. They realized that more is better. Except that the quality was much worse, right? So you got more, but you lost quality. I learned a lesson, actually. I pushed them hard for a month. I kept getting annoyed. And then I realized this is not the way. I created in India, I got hold of a Englishman. I went to the English department in a Delhi university, right? I got hold of people who were just finishing their PhDs in English, in communications, in marketing, etc., etc. And then, actually, this is a gold mine. It's a very interesting experiment. I should talk about it. This is how problems are solved. I needed people who would really care about it. So luckily, I latched upon a person who said, you know, I am waiting to go to Oxford. That I'll go next year. I have gotten into some program, whatever it is, postdoc, whatever it is. But till then, I can't take up a job, etc. I do need money. I said, well, here's your problem. You need to create for me data like this, search the web, study it, evaluate it. Here is a rubric. It must meet all of these criteria and produce the result. Single-handedly, that young fellow did, in one day, he produced more result than a whole team of 20 data scientists had produced in a month, and better results, right? That went at it. Then we created a team, actually ended up creating a team. And I realized that India has untapped resources. Yeah. And by luck, I ended up with actually a young girl. She said that, you know, I have a background in communications. And she did amazing work gathering this data, labeling data. I asked, bright person like you, how come, you know, you're doing this job? And she said that, see, as if My parents married me off, and my in-laws now expect me to be at home. Right? I'm getting bored. How much exactly can you do all of this stuff? So this is a pleasure to do. It is far more interesting to do this than just sitting and watching some TV shows. Right? So she jumped into it, and then gradually, all sorts of oddballs like this, people who are doing different walks of life, they gathered, and I gathered a team of 30 data labelers and data gatherers, and they were amazingly productive. And therein, I mean, if you're into strategic leadership, you know the lesson that I'm driving at, that every problem is unique, and you should not use the talent pool you have because it's a misalignment. That talent pool was hired to do something else. Forget about them. Look at every problem uniquely and ask who would be a best fit to do that. And by the way, to my engineers, I can now, I suppose, talk about it. I was paying close to 1 crore a year in salary. I don't know what it is these days, but I'm talking about the pre-pandemic days. 1 crore a year in Bangalore. No, for my data scientist. Guess how much these data laborers are costing me? How much were they expecting? Basically, the best of them, they were getting 12 lakhs. And the very young ones who just wanted to do, they were getting some 7 lakhs. I wanted the good ones. Like I wanted, and they felt grateful. They said that this is a high pay. So I was getting 10 for the price of one, even in Bangalore. And literally, one of them was producing more work than 20 of them 20 engineers produced in a month. So it's a lesson. So when you create validation data sets, guys, don't ever go to somebody with engineer in their title. This is the first lesson of AI, where practical lessons, these are really strategy. You know how the ChatGPT was trained? Where did the data and the training, data labeling come from? Anybody knows? Engineers did it? No. It was done by Nigerians paid $1 an hour. That's why you notice that in the ChatGPT.
They're anyway rich. Nigerians. They have a lot of money.
Yeah. Yeah. No, but by the way, those things. So many people don't realize that all that East Coast, East Africa, and the Nigerians. By the way, Indians have a huge presence and a history there. The British Prime Minister of India, the Indian Prime Minister of Britain, was actually not Indian. He was a Hindu, but he was actually East African, right? Tanzanian. Yeah. So anyway, there's a very high literacy of the English language. But you can tell the language because if you notice, ChatGPT will give you answer with statements like, in the realm of, let us delve into this. Have you seen these cliche statements come out of your ChatGPT? So apparently people have done statistical analysis and found that these things are much more common in Nigerian British English than in American English. Right? And so the ChatGPT has been sort of trained on that English. Right? Anyway, practical real life example. Guys, if there's one thing I can tell you about leading large AI teams, I will tell you one thing. Always complement your AI team, engineering team, with a proper data team. And that data team, make sure that they never, ever hire anybody with an engineering degree. Right? Engineering degree should be a fireable offense there.
And they should not talk engineering,
Yeah, they should not. Yeah. That is reality. Anyway, so that is your MRR. Right? So
what you really summarized here is that the importance of the validation.
Yes.
That is it.
Yeah. Of course. Testing is very important. So now I'll come to a term that people have a hard time understanding. Mean average precision. Math. Precision. Now you notice that there is some redundancy here. Mean and average are the same words. synonyms, right? What do you mean by mean precision or average precision? So to understand that, let us go to the word precision. Can somebody tell me what is precision for a classifier? What is precision?
Accuracy.
No, it's how correctly you're identifying the positive. It's true positive, false.
Aha.
One-
Give me an intuitive answer that a 5-year-old can understand. You're giving me a formula, TP over this and that. That means you don't understand it. Okay, let me make this. There are 3 things when you talk of a classifier. There are 3 things that matter. So, okay, let me take a digression.
Predicting the positive class, is that it?
Accuracy, precision, recall. And F1 score, which is basically harmonic mean of precision and recall. So I'll take a, by the way, guys, if you are all clear about the meaning, I won't spend time on it. Otherwise, I'll give you guys a quick refresher on this because it's important. How many of you would raise your hand if you want a refresher on this? Almost all of you. Okay. Yep. So the term that is most often used actually is the one, accuracy. Accuracy is right answer versus wrong answer, the errors, right? So people are often tempted to say, okay, given a query, I know that the only right answers are, like I know the right answers, R1 to R10, and anything else is the wrong answer, right? Suppose the results come out, something right, something wrong, wrong, right, wrong, right, etc. Right? And or even this, right, wrong, 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 right, right. Look at this answer in that order. Is this a good search result? What is the accuracy here? You could say 3 right answers, 1, 2, 3, 4, 5. So 3 out of 8 right answers. Accuracy is 3 out of 8. You can say that, right? Now you say, well, that's pretty bad. And suppose I give you another situation. Let me call it case A. Let me give you a case B. Right, 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 wrong, 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 wrong. What's the accuracy here? 3 out of 8. But is there a difference between the result set A and result set B? Which one would you prefer? Why? The right answers are ahead, right? Or in the language of MRR, it has a better MRR score, isn't it? What about? No, it is in that sequence. The results came out best. The machine claims that the best result is, it gives you in the decreasing order of relevance. Search results will always give you an order of relevance. Yeah. Right. Now observe something else about it. Suppose that you take a third result, which is like this. Wrong, 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 right, 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 right. What's the accuracy of this? Would you prefer C or B? Still B. So what is the lesson that you learned from comparing A to B and C to B? When you compare A to B, they have the same accuracy. And yet you prefer B.
Predicting correctly.
Now, basically what you're alluding to is the fact that accuracy is not a good measure. You realize that, right? This becomes even more clear when you compare C to B, C is actually more accurate than B. You would still prefer B, isn't it?
Yeah.
Because the order, how early on the good results come matters, right? So, well, so accuracy is out of the window. That explains why you should, people do use, by the way, I've seen so many people just say, oh, we are getting good accuracy from our search. Duh. Like, you can always spot a novice. Okay? Mention other useful metrics. Right? So, the word shibboleth. There's an English word, shibboleth. Can somebody look up its meaning and tell me?
C-O-S.
SH. Shibboleth. There's an interesting story behind it, I'll tell you.
Custom or tradition, usually a choice of phrasing or single word that distinguishes one group of people from another.
Yes. Where's your microphone?
I don't
Steal one
know.
from somebody.
Yeah.
Yeah. So say it for everyone.
A shibboleth is any custom or tradition, usually a choice of phrasing or single word that distinguishes one group of people from another.
Nice. So I often say, so I'll tell you the story of shibboleth. What happened is that there was I think it's a Hebrew tribe. They wanted to protect their identities, but they feared that intruders will fake to be them and then harm them, right? Know their secrets and attack them or do something to them. There's a bit of history to it. So they could always tell who the outsider is, because the outsiders, when they were given this word shibboleth, they would say shibboleth. Because the literal writing in Hebrew is shibboleth. So they wouldn't know the shibboleth. So you could know, okay, this is an outsider. So every sub area, everything, the tribe of people who do search, let's put it this way, a machine learning tribe, it has its own shibboleth, and you can always spot an outsider, right? And here is a way for you to spot an outsider. It is, to use accuracy is like to be the guy saying shibboleth.
Oh, it's like COVID. It's like COVID. Anybody newly coming from India, JOSC, they say Jose.
Yeah, Jose instead of Jose. That's right.
Yeah, I'll let you know.
Even in the movie, the Inglourious Basterds, they got found out.
Come again?
Yeah,
The movie Inglourious Basterds, there will be a famous bar scene where these guys be there, and they have to say three.
Yeah.
But Germans say it in a different way, three.
Oh.
These guys will say three, and that's how they will get right out.
This is English way of saying three.
Yeah.
And Germans say like that.
Like this.
Oh,
So
shibboleth, exactly.
And then we
Right.
This is approval.
So
Not getting into that.
I'll give you another way why accuracy is usually a bad idea in most situations. See, think of physicians. Have you noticed that antibiotics were discovered after the Second World War? Penicillin was discovered after the Second World War. When somebody discovered that a fungi colony can go attack and prevent a bacterial colony from growing, right? That's it. And so that's therefore the penicillin. So a modern medicine pretty much dates after the discovery of the penicillin, and around that time, most of the modern medicines were discovered. You probably know that before that, we lived in very horrendous times. Surgery was done without anesthesia. You would be tied down and they would cut you open, right? Most medicines that you were given, today we know by the light of modern science, were actually useless. Literally useless, right? And yet but that didn't prevent medicine as a field and doctors from existing in every culture and every time. Go back 10,000 years, there'll still be a very confident doctor. And you go to him saying, I've fallen sick, and he'll say, my dear boy, don't worry, you'll be fine. I'll take care of you, right? And the whole culture, the whole tribe would have tremendous faith in that physician. And the guy would mix up some mixtures and give it to you. And a few days later, sure enough, you're fine. So I'll ask you this question, since you guys are all doing machine learning and AI. It's your job to reason with data. What gives? Why is it that throughout history, people have had such tremendous confidence in physicians, even though by the light of modern science, we know that much of what they were giving out was nonsense? Go ahead. Into the microphone, please. No, placebo effect only works for pain. Placebo effect was discovered in the First World War. As you know, there's an interesting story. The morphine did not arrive to a battle camp. The people were wounded. It was getting dark. And the medical camp was frantic. They had been waiting for morphine and the medicines to arrive, and they had not arrived. Till one nurse had a bright idea. She couldn't bear the pain of people. And or was it the physician? Gave the order, all right, do one thing. Just take sterile water, and to all these soldiers, give an injection of sterile water, saying it's morphine. They did that. It was an act of desperation because the soldiers were all crying out in pain and asking for morphine. There was no morphine to be had. And that night, the camp was quiet. The soldiers slept. Right? So that is how the placebo effect was discovered. People have later on ascribed placebo effect and said it cures, you can cure cancer with placebo effect and whatnot. But, and for a long time, people actually did believe that some of it may be true. But recent reinvestigation of all the cases has shown that placebo effect more or less only works for pain. It doesn't work for other situations. So placebo effect cannot cure illnesses.
Is it hope?
Hope?
Faith in illness.
Well, faith, healing, and hope, etc., has been around for a very long time. Though I wouldn't say hope per se cures you or decreases your pain. It doesn't do that actually, or cures you of illnesses. Though, see, since you brought it up, and this obviously I'm going into a personal philosophical tiny. It was best expressed by the philosopher Buddha. He says that, see, when you're stuck with an arrow, you have the pain, the physical pain of the arrow, but you also have the psychological pain. Why me? Why am I suffering? And how dare he shoot me? And I'm going to really take revenge, and all of that is going on. So there's a lot of psychological suffering. So as Buddha pointed out, that the only thing being a little bit wiser does is you don't have the psychological suffering, but the physical suffering is there. You can't take that away. You just cope with it better. So your faith and your hope can help you cope with it, but it cannot take your physical, it can cure you of diseases. So what do you think was happening? I'm asking as a scientific question, and it goes to the heart of accuracy. See, here's what happens. Most diseases are self-limiting. Human body and all of this, life forms, mammalian bodies and all of these animals, you will realize that it has a almost miraculous ability to heal itself. You realize that fishes don't have physician fishes amongst them, right? And yet they have survived and filled the oceans. So it's because biological systems are self-healing to a large extent. So now a patient comes to you and says, oh, I'm really having a tummy ache and this and that. And you are a quack, let's say, but you don't know that you're a quack. Usually most physicians, they think they really know it, right? But actually, obviously, you can't imagine that 100 years ago, the physicians were fooling people. They were not dishonest people. They had been taught all these techniques by their medical school and their professors. So they believed in all of that. So they said, my dear boy, I'll take care of you. Give some hocus pocus thing. Carminative, have you heard the word carminative mixture, right? They would just grind something, put it in water, then give it to you in a bottle, and there would be colored bottles. I've actually lived through that in my childhood. I went to a boarding school where for every illness, for fever, there would be one Carmitav mixture. For cold, there would be another Carmitav mixture. Upset tummy, there would be another. And they would do that in the pharmacy. So this person goes home, disease is self-curing, and he gets cured. What does this person think was the cause of the cure? The physician, isn't it? But this is because it's one of the biggest fallacies. If X happens after Y, we tend to give credit to Y for causing X. You see that in politics, right? Every president of the United States, irrespective of which party it belongs to, when they come to power, everything good that happens, they say, I did it, right? And everything bad that happens in their 4 years, my goodness, look at the mess my predecessor left, right? We all do that, right? So there was so in other words, that's the fallacy of sequence, right? So I say, so if my way of saying it is that, see, I came to Silicon Valley in the late 90s, and there was a dot-com boom. So guess who caused it? So there is that. There is also a confirmation bias in terms of the physician. Physician has been taught in school that this medicine works, right? He gives that medicine to a patient. The patient gets cured. So what does it do to the physician? It creates a confirmation bias that that textbook is correct.
People online, did we lose the...
He has a model, diagnostic model. 99%, right? Because there's a class imbalance. Only 1% people die of illnesses. 99% get cured automatically. Therefore, I hope all of these stories I'm telling you to convince you never to be duped by accuracy.
Yeah.
Accuracy is a useful measure, but it has to be contextualized with other things before you take it too seriously. So if accuracy won't do it, what is this precision and what is this recall? So let me answer this question with this. Recall is literally that. Suppose I tell you 10 words, right? I say potato, carrots, cabbages, cauliflower, and so forth. And then after some time, I keep, this is a typical memory test, mental care people do. Actually, my daughter does it on patients. And they'll have a nice conversation. And at the end of that conversation, half an hour later, you would say, okay, do you remember what words we talked about in the beginning of the session? Right? And so the number of words that you can correctly recall, it is a measure of how good your memory is, isn't it? I ask you to give 10 words. A good answer would contain all those 10 words. Does that make sense? Right. So that is recall. The number of correct answers over all the answers. On the other hand, what is precision? Precision is the opposite. So recall is the ability to surface in your result that which matters. Right? So suppose I say that, and let me contextualize it in a different story. See, these days, you will soon, one of these days, reach my age. Right? When you enter middle age, some things you have never thought of, the physician will start sending you for, right? Actually for women, it's even earlier. Women, there's always a fear of breast cancer. And men, there's a fear of, for example, prostate cancer, colon, whatnot. There's a whole bunch of diseases. So in a regular checkup, we all go through some screening test. In a screening test, say one of two outcomes could be there. Either you can have a tumor or you don't have a tumor, isn't it? The other aspect is the diagnostic tool. If you think of it as a machine learning model, it will predict that you have a tumor, or it won't that you don't have a tumor, right? So if you make a matrix of reality versus prediction, let us say that the reality is, yes, you have a tumor, no, you don't have a tumor. Machine predicts that you have a tumor, and machine predicts that you don't have a tumor along this way. Right? It is what is called your confusion matrix. An ideal machine should have 0 and 0 here. Right? It never confuses. It never tells a guy without a tumor that you have a tumor. It never tells a person with a tumor that you don't have a tumor. Right? This is false negative. This is so what is a good as a screening test? What is valuable? What is more harmful? A false negative or a false positive is more harmful as a screening test?
False negative.
And justify that answer, Roy. You're correct. Why?
So basically, if it says there is no tumor, the test if for example, if it says there is a tumor, if we do further test, it won't create a harm in the long term in this case of domain of doctors. But if it is a false negative, then the treatment will be missed and he might die.
Absolutely. Thank you for saying that. Very well said. See, guys, here's the thing. It's a screening test. If they mark you positive, you'll anyway go through subsequent tests, right? So let's say that you went to the physician, you came back, and he says, hey, we need to do some more tests. There's something worrying. So you know, you have been marked as having a tumor. One of two things can be true. Either you have it, in which case it's an early catch. Good job, the screening succeeded. On the other hand, you don't have it. At most, you'll have some drama, you'll go home, you'll cry, your family will cry, you'll write some poetry, drink some wine, right? Then 2 weeks later, you'll come back and it'll turn out you don't have it, right? So all is well. The only thing you shouldn't do is take up a big loan and spend that money. So on the other hand, if it is a false positive, false negative means you had a tumor, but the machine missed it. What will happen? Tumor will progress. By the time you come back for the next annual checkup, probably it's gone to a more advanced stage. The biological toll, the psychological toll, and the financial toll would be enormous, isn't it? So you would rather have a little bit of drama than a huge real loss at the end. So in the machine, what do you want to have? You want to catch all the positives. So you want a high recall, isn't it? Just like in the case of that person whose memory you're testing, you say, tell me the words I told you. Suppose the guy does tell you those 10 words, but then also inserts some turnips and horseradish in there, in that list. It doesn't harm. It means that, the guy is sort of, the memory is still intact. It could recover the 10 words properly, isn't it? So a few words that are not really there, right, it doesn't hurt you. Most importantly, you should catch the positives. But then now, so you need high recall. In the screening, you sort of need high recall. Now, look at the other end of the spectrum. The guy, the subsequent test, there's one final test. If that test says you do have cancer, there's a surgeon sharpening his knives, right? Flashy knives are being sharpened. Operating theater doors are wide open, right? and you're,
Great on the wrong.
that's right. And you might just be rolled into the theater. But there is one test. If you come out negative in that test, it means you don't have cancer, hopefully. But if you do come out positive, you do have cancer. In that test, what matters most? False positives. You don't want to have a false positive, right? You don't want to do an invasive surgery and quite literally remove a body part from a patient when the patient was perfectly fine. So what do you need? Low false positive. You need a situation that everything that your algorithm marks as positive truly is positive. Does that make sense, guys? So at that moment, you need high precision as a final test before the operating theater. You want high precision in the diagnostic tool. So do you see the difference between precision and recall? No. And it is the context, the situation that determines which one you focus on. Am I making sense now? I hope I've given you. So guys, when you see these words, accuracy, precision, recall, don't immediately look up the formulas, TP over P, BT, this and that and so forth, because you'll forget about those formulas. Did you forget about it? Yes. So don't, and most of you don't even remember the formulas, right? Okay. Yeah, I know. So always associate. See, I keep saying this again and again. Human beings respond to stories. You want to remember something? Remember it with a story. Right? Think of a situation, and that situation will give you a logical answer. So remember precision, recall, and accuracy the way, using examples the way I taught you, because then you'll remember it. Otherwise, you'll forget it. Otherwise, just a formula, it will escape your mind. So now when you're looking at search, you're getting many search results. What would you like? You would rather that those search results be valid search results, isn't it? You do care for precision, right? You do care for precision. So now let's focus on the precision part of it. Suppose you have a query Q, right? QI. It produced a result A, B, C, D, E, F, G, H, I. What you do is you box it in like this. Suppose I were looking at only the one result. What is the precision of this result? It is either 0 or 1. If this result is a valid document I wanted, right? So the precision can either be 0 or 1, isn't it? Now let's look at, so what you say, let us say that this is a correct document, hypothetically. Let's say that this one was correct. And let me just randomly put tick marks somewhere. This. How about this? 4 documents correct, right? So the first one looks pretty good. Top one result, you have a winner. Precision 1. So you're looking at this. Now you go and look at the top 2 results. What about now? What's your precision? Half. Half of them were right, isn't it? So then you go and look at top 3 results. And now what's your precision? 2 by 3. And then you go and look at the top 4 results. It is 3 by 4. And then you continue on, and then you notice that if you go to this one, E, it is 3 by 5, right? Then it becomes, let me use another color. It becomes, what does it become? 4 by 6. And then it becomes 4 by 7, 4 by 8, right? So 8 results. So you realize that suppose all of them were good results, your precision would have been consistently 1. But it is varying. So you can say, what you can do is you can average the precisions. and say that the average precision was summation of these values and divided by 1/8. Does that make sense?
Mhm.
And that's your average precision. It would say that, okay, for this query, how well it performed.
Mhm.
Exactly. Absolutely. So then what you do is you have only one query. Go and repeat it for your 100 or so queries, right? And keep computing the average precision. So then average the average precisions, right? It's called mean average precision. Right. So let me just call it AP1. So what you do is 1/100 of API. AP1 plus AP2 plus average precision of the 100th query. You got it, right? So that is why it's called mean average precision. It's one of the tricks, by the way. Whenever, just give you a little bit of a aside and then we'll take a break. Whenever I interview people, so there's a tradition in Silicon Valley, which is a one-upmanship or making people feel bad, right? Have you seen that? There's 6 rounds of arduous interviews.
Yeah.
And many of the interviews, the interviewer will growl at you and look at you, or will sit on a high horse and sit on judgment on you. Yeah. Puny little you at the other end of the desk, right? While they are, of course, the arbiters of your fate. Yeah. They'll do that. So it was my fate, actually, 10 years ago, to be, because I chose to, I was questioning, I was looking at an interesting question. What makes people happy at work? And I wanted to answer that question using machine learning. It was an odd question. But then I tend to do odd things. Like, for example, I gave up a perfectly good career to become a humble teacher now. So at that time, I was another phase of life. I was doing that. It turned out to be actually very useful. So a startup wanted me to lead their team. And then it did have national impact. But anyway, we'll leave that aside. So I was looking specifically at the efficacy of the interview process. There's a whole subject actually in industrial and organizational psychology called selection science, which asks the question, what is the right way to select people for hire? And engineers, of course, don't know about it, but I went pretty deep into it and was applying a mixture of that and mathematics and AI techniques and systems thing. So I looked into the interview process that's happening, that's prevalent in Silicon Valley, and I consider this to just be a tribal ritual. There is no head and tail. There's no scientific evidence whatsoever that it helps you pick a better candidate at all. No scientific evidence at all. And I say that while we are doing this research, the head of Google, HR, Google people, was on our board observing what we were researching at that time. Right? And I would like to believe that our findings did influence some of their practices. But the fact does remain even today, and Google acknowledges that despite a very careful process, all we can do is say we tried, but our results are very depressing. Very depressing. We cannot confirm that this is any better than throwing a stone at a bunch of resumes posted on the wall and picking the one that did it. Right? It's really that bad, right? So the question therefore arises, because I've been asking this question very deeply for many, many years. How should you hire people? So while I don't have objective answers, I have a subjective one. First thing is treat people with respect. If people are happy in your room, they'll show you the best, what they're made up of, right? If they feel confident, if they feel you're liking them, they will really show you their best. And you want to know their best, not their most scared self in which they'll underperform. You want them to come out with their best. But at the same time, you need to quantitatively assess them. So in all my interviews, I always ask questions such that there is at least one good answer everybody can give. Right? But there are deeper answers that only people with significantly higher maturity in the topic can give. Let's say you can scale it so that you need to, like, I feel to me it matters that people should go out feeling out of the interview with me feeling they had a positive experience and they did well, right? And everybody has a place, you just, my job was to determine what level they'll fall, what level to place them at, because obviously juniors had already interviewed those candidates before they were shortlisted and sent to me. So things like this, these are exactly the sort of question. I would say that suppose you have a search engine, how would you assess the goodness of that? So a typical thing. Some very basic things that I would ask is, and some things admit a lot of good answers, a whole slew of good answers. For example, if you have a whole lot of numbers coming at you, and if I ask you to find the value that is at the 79th percentile, how would you find that? Right? An easy answer is, what's an easy answer? You would start by sorting them, right? You sort them and pick that at the 79th percentile or 23rd percentile, pick a number, right? But there are actually more sophisticated ways. Now you answer them. Then you ask, okay, what if the numbers are coming nonstop at you? What do you do? Right? They're continually coming at you. How do you do? Or another question that you get. Then what happens is it gets sophisticated, and many of you probably know the answer, the technical answer to that. It gets into sketching algorithms. You have to be fairly mathematical, and you'll get those answers gradually. So the bottom line is, for me, search and this sort of question is often a staple diet for interviews because everybody can give some answer. Even the naive person will come and say, okay, let's look at the accuracy of the search results. It's not a bad answer. It's just not the best answer. And you can move up that thing. So guys, next time you show up at my interview by any means, right, don't say accuracy. Right? Because if you see me smiling, it doesn't mean that
You're happy.
Right. So that's that. So with that, I'll take a break. Sajay, go ahead.
So I look at that number,
Yeah.
very clear. 4/8 is accuracy. And as you're talking, I understood that. My question was, what is precision is primarily the average per query.
That's right.
Now, how do you say recall with that example? Actually,
Recall, you have to know what are the right answers that it missed.
oh, that it missed.
That's right.
That is not there in the
That's not there in that, yes.
How do you know?
You know that because you created the data set.
Oh, of the 100,
Yeah.
you only take 10.
Yeah.
What?
What are the things that it missed?
Oh, that's the number.
That is it.
Got
Yeah.
you.
So guys, here it is. This one is easy. 8 by 8, 4 by 8. And you can keep on doing it. You can normalize it and find out what the average precision is. So this is average precision. So guys, what did we learn? I hope we finished the topic of RAG. Not RAG, of hybrid search. Can I ask you guys, because this is a very practical thing, use VM25 and get search, just use the Python library. It's very easy. And apply it to the same documents, get the search results through keyword search, get the search results through vector search, pass it through a reranker, and look at the results. Can I please expect that from you but before next week, guys? Because if you already have the pipeline, just the search part of it, you'll see that you get much better results. Sanjay.
So what is the current state or any analysis? I kind of intuitively think, what is the real use of keyword search anyway? In high
No, because sometimes people use very few words and there's not enough semantic content in it, in the query.
Oh, okay.
Sometimes we don't type in.
Oh,
Slow
not
words.
right. Okay. It's not really sentence.
Yeah,
Yeah.
it's not enough. See, semantic search benefits when your text is long, query is descriptive, but people are so used to just entering 1 or 2 words.
Makes sense. Thank you. How much break?
Let's take a, guys, 20-minute break. We'll meet at 3.
Okay. Here it goes.
By the way, was it fun? I hope you guys were having fun with
This was
this.
very interesting.
Yeah.
I think I
So
like the stories that you recorded.
yeah.
Hmm.
Pretty good.
Say that I have space.
I went to get some of this one.
Yeah.
I got 3 of them because there's so many of them.
Okay.
Where?
Because I bought them.
Oh.
Because I was busy.
Yeah.
3, they had 3 left. I got 3. So this one I don't have space for, so I literally.